thrown on to sick and find nobody else to do it.
I usually just want to get broken at the bar playing pool.
Good morning. We're halfway through chapter 6, and a week from today is our next test, so that's really great. Over chapters 5, 6, and 10. 5 and 6 should be okay. 10, I don't know about yet. We'll figure that out when we get there. So, last time we did Hamilton's paths and circuits, complete graphs, traveling salesman problem, and today we will do brute force and nearest neighbor algorithms, and to try to get the cheapest way to go someplace. Brute force means we do every single possible path to see which one's the cheapest. That's what that means. Make a list of all possible Hamilton's circuits on the graph, and for each one figure out how much it's going to cost, and then choose the one that's the cheapest. Works fine if there's only 2 or 3 places to go to, or it doesn't work fine very well if there's 100 places to go to. Nearest neighbor, we're going to start at wherever we're supposed to start, and then we're going to go to the one that's cheapest from there, and do the same from there on until we get to the end of the path, and we're going to say that that's as good as we want to get for the money we want to spend. So we're going to go for each of the middle steps again. For the last step, we're going to go to the last place. Okay. Pros and cons. Brute force takes a long time, but gives us the optimal path. But will be impossible if we have to go too far. Practical terms. 10 vertices means a mere 362,000 different things to do. Clearly we wouldn't want to do that. So if there's 30 vertices, it's going to take us 284 million years to figure it out. I don't think that's going to happen. Well, for a computer to figure it out, not for us to figure it out. That's pretty bad. Somebody should be able to figure out how to program the computer better than that. So we'd say that this is an inefficient method, but it would be an optimal method, which of course is question number 1 on the quiz. So that should solve that problem when you see it. Nearest neighbor, we hop from vertices to vertice. We have a simple criteria to follow. It should be pretty quickly to get done, and it doesn't. And we can do it with, if we have 30 ends, 30 points to do it from, or 10 points. It won't make any difference, and it should be pretty efficient to do so. So it is a efficient logarithm, but it's not going to get us the optimal answer. It's just going to get us a answer. Example 6, 7, which we all don't remember what it is whatsoever. Nearest neighbor would give us $773, optical 670, whatever. There's a $97 difference between the two. Isn't that lovely? Oh, relative error, you take the cost of the tour minus the optimal tour divided by the cost of the optimal tour. In order to calculate the relative error, you'd have to know what the optimum tour was. Sounds like a pain. So it's good, but it's no good, because if you have it, then you know what the optimum tour was, and you'd take it anyway, and you wouldn't need it. Okay, looking at problem number 35 and seeing whether or not we can solve it.
We did 35.
We did 35?
Yeah, we're on 37.
Doing number 37. That's probably why that thing is at 37 and not 35. Nope, can't do it yet. Darn. Moving on to section 6. approximate ways of doing this, approximations. Lots of words, not much there, not much there either, not much there either. No, not much there. Time and money. Well, done with that one. Moving on to seven. Tell us something, author. Repetitive nearest neighbor law algorithm, which is what 37 tells us to use, so it's about time we get there, right? As one might guess, repetitive nearest neighbor is a variation of the nearest neighbor one, in which we repeat several times the entire nearest neighbor process and until we get something that we like. Since finding the nearest neighbor tour is an effective process, it's not unreasonable to repeat the process several times to see if we can get a different answer. What you do is you start somewhere other than the vertex you really want to start it from. That's not a problem because you're going to get there anyway. So that'd be okay. So we want a tour of 5 cities. We computed the nearest neighbor from A. And when we did that, we got 773. So what we're going to do is we're going to not do it from A. We're going to do it from B, C, D, and E. We're going to do the nearest neighbor from each of those. So we do it from B, and we find a cost of 722. And we do it from C, and we kind of find that the total cost is 722. And we do it from D, the total cost is 722, and from E it's 741. And now we can pick, among the nearest neighbors, we pick that guy, which is 722. Which is the one we already had. No, because now we go back a route that we wouldn't have gone, because when we did the A route, we would have gone A to B, I think. Yeah, I'm pretty sure that's the case, but we're not doing that now. We're doing, so repetitive nearest neighbor means we go and do the tour from each of the things, nearest neighbor tour, and then do the one that's the cheapest. Nearest neighbor, blah, 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 x beta vertex, blah. Okay, excellent. Now we can work problem number 37. Use the weighted graph shown below to find the repetitive nearest neighbor tour. Write the tour from B. Okay, so we'll do the tour. What in the world is this thing here, I wonder? No, we don't want to cancel it. Okay, so we're going to do a tour starting at A, and from A we go to D, and because it's the cheapest, from D we're going to go to E. From E, we're going to go to B, and from B to C, and C back to A. And then we'll write down some values, 3.1, 2.2, 3.8, 3.6, 3.3. We'll add those up later. And then we'll do the same thing, and we're going to start at B this time. So I start at B, and cheapest route is back to A, and from A it's to C, and from C, D, then E, then back to B. We write down some numbers, 3.2, 3.3, 2.4, 2.2, 3.8. Okay, and we'll do it again. This time we'll start at C. C to D, E to E, E to A, A to B, B to C, okay? So I started at C, 2.4, 2.2, 3.4, 3.2, 2.6. Okay, almost ran out of colors. Now we're starting at D. So if I start at D, I'm going to go to E. Then A. And B. Then C, back to D, which is the same as above, so we don't have to write down any numbers. That's no different than the other guy. And now we got to start at E. So from E, I would go D, C, A, B, E. 2.2, 2.4, 3.3, 3.2, 3.8. Alright, so now it's time to break out your calculators, or we can just do them in our head, I suppose. 2.2, 14.9. Fourteen point eight. 14.8. $16. 14.9. Okay, so these two here, which are the same root, would be the minimum one. So we want to start where?
Either C or D.
We wanted to start at B. Okay, so we want to start at B. So final answer, B to C to D to E to A to B. So I can use the green guy, B, C, A, D, E, B, or I could use this guy and go the same way, B, C, D, E, A, B. So they're the same route either way. Well, isn't that special? Now we'll move on to see if we can do 43, or if there's something weird going on there. 43. For the weighted graph in 46. Now, the 46 graph and the 44 graph are the same. I wonder why they did that. Notice that they're the same? Anyway, for the weighted graph shown, find the cheapest link tour. Starting with B. Note this is the graph in exercise 37. Okay, well, as I recall, we haven't talked about a cheapest length tour, have we? That's because the cheapest length tour is in 6.8. Okay, well that solves that problem. So that means we have to do 6.8 before we can even talk about a cheapest length tour.
Well, the one for 43 is the same as the one we did for 37.
Yeah, I know. Isn't that great? It would seem like they would both come up with the same answer, right? Seem that way. The idea behind cheapest length is to piece together a tour by picking the separate lengths of the tour on the base of cost. Well, isn't that what we're doing? It doesn't matter if in an intermittent stage the links are all over the place. If we're careful at the end, we can come up with a tour. Right, this is how it works. Look at the entire graph and choose the cheapest edge on the graph, wherever it may be. Once this is done, choose the next cheapest edge on the graph, wherever that edge may be. Don't worry if the edge is not adjacent to the first edge. Continue this way each time, choosing the cheapest edge available, but following two rules. 1, do not allow a circuit to form except at the very end, and 2, do not allow 3 edges to come together at a vertex. A violation of either of these rules will prevent the formation of the Hamilton circuit. Okay, so we're going to pick the cheapest link, and then we're going to pick the next cheapest link. And we're going to do that except to finish, and no 3 things in the same one. Okay, got it. Since finding the nearest neighbor tour is an effective process, it is not unreasonable to repeat the process several times. Repetitive nearest neighbor. Each time starting at a different vertex in this way. I think we just did that, didn't we? All right. So here we're going to do cheapest link. So there's my first link, 119. 120 is my next cheapest. We can't use 121 because that would be 3 going into the same spot. That doesn't work. And we can't use 133 because that would end our graph in a circuit, so we can't pick that one. So the next cheapest, we get rid of them. 152 can't be picked either, but they picked it. Well, I guess they can pick it. The next cheapest available, and it works just fine. Okay, right, because we haven't violated any rules yet. And the 5th link would be there, and now everybody's connected. Okay. Pick the cheapest link, blah, 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 pick the next cheapest link, continue, but don't close the circuit, and don't have 3 edges coming together. Connect the last 2 vertices to the end to make sure that it works. Okay. And we're going to do this on the red planet. I don't know, with my trifocals, I'm not sure I can find the cheapest. Like, oh, here it is down here. This guy here looks like the cheapest. Okay, for this thing, if we use brute force, 727 different ways to do it. Cheapest logarithms are reasonable to be used. All right, excellent. I was right. Use the 1,300. And then we pick those guys. No, we can't have them because it closes off. This is a tie, but we can use them both. Those guys we can't use because it either finishes the circuit or it comes to 3. P we can't use for the same reason. We go there, now we're done. And when we get done, we get something that looks like that. 21,400 miles. Did you hear the bad news today about Mars?
Who?
Mars. Well, we have all these cool rovers on Mars roaming around right now. I think we have 3 of them total that are there. Some are better than the others. But the Earth is here, Mars is there, the sun's in the middle, we don't have any line of sight, we can't talk to them. So we took all our rovers and told them to go to sleep, sit there and charge your battery until we get back to you when you get past. Yeah, I know.
Roger Ebert died today.
Did he die today?
Mm-hmm.
I didn't think he died today. I just thought he retired today.
No, he died.
He
Well, I seen
retired.
something on
He
Facebook.
retired and died at the same day, huh?
I don't know, I just read
That's the
something
way
on
to go.
Facebook that he died.
That's the way to go, though. If you're gonna do that, might as well.
Cannot be true.
So our robots or whatever are just sitting on Mars,
Mm-hmm.
doing nothing.
Just chilling.
They're charging their batteries. They were given a command to just shut down, charge your batteries. We'll get back to you later.
That's a waste of money.
Well, but we don't want them roaming around without us telling them. So they're not independent.
So yeah, but didn't we get through them? How did we get through them in the beginning when they were running around doing whatever?
Yeah. Well, we were telling them to do that.
Us and Mars, so we can't.
Well,
get
so
to
the
them.
sun wasn't always in between us
No.
and Mars?
No.
No,
Oh, just temporary?
Yeah.
Yeah.
temporary thing. The sun is just an itty bitty thing, and we're way far away, and so yeah.
It's destroying our communication. So instead of them roaming around and getting stuck in some giant hole where we can't go save it and lose tons of money, they just told it to go to sleep.
Yeah, we just put our rovers to sleep and let them be okay. It'll be okay. They'll love us still when we talk to them
The
again.
alien's gonna pick it up and take it with him.
Probably, yeah. All right, so here's the tour going that way. All right, nearest neighbor. Nearest neighbor is the simplest of the algorithms. So blah blah blah. Okay, there's nearest neighbor. Fine. The first surprise is that nearest neighbor gives a better tour than the cheapest link tour. Sometimes that happens. You have days like that. Second surprise is that the nearest neighbor tour turns out to be the optimum tour. You can't, even if you use your computer and found all the other ones, you'd still be there. Well, isn't that special? Now we're on 43, and we can do a cheapest length tour. All right, so in order to do a cheapest link tour, I think we need to have an A and an E and a D, a C, and a B. And then we ought to go and hook them together. Boom, 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 boom. Okay, is everybody hooked together? Yes, they are. All right, we'll do everything except we won't bother to put numbers out there. Okay, so where's the cheapest one?
D to E.
All right, so we're going to pick that one. D to E first, 2.2. The next guy is 2.4, so we can pick him. I can't spell. Anybody have a better reason than that? I already used my trifocal excuse, so I can't use that any more than once a class. So I think I'll stick with I can't spell. Is that okay? Where was I? 3.1 is next, but if I use 3.1, I can't use that one because that would give me 3 on the same path. So I'm going to get rid of 3.1.
Do you want us to draw the diagram or just write down what you're saying, like D to E and then D to C?
Yeah, I think letters would be fine. Yeah. It'd be much better if you all had interactive computer systems that did multicolors. Yeah, but we're probably not going to do that this time. 3.1. 3.2 is the next guy, I think. So that's A to B. And then 3.4 and then 3.6. Looks like I'm done. All right. I'm going to choose A, B, C, D, E, A. But I'm supposed to write the tours using B. Okay, so I go B and end at B and get rid of that one. And do I have to, what's the cost? Write the tour, blah, 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 find it, and write the tour. Okay, it doesn't, I don't have to add anything, so. Final answer, that guy there. So it's the method that counts. That was 43.55. Suppose that you are told that all possible friendships can be deduced from the following information. Just what? Just what we need, some special friendship map. Isn't that lovely? Draw a friendship graph. Find the possible sitting arrangements for the party. Suppose blah, blah, blah. What party? Is there a possible seating arrangement in which A and E are seated next to each other? If there is, find it. If there isn't, explain why. Okay, so clearly we are only going to deal with a round table, I think. Okay, draw a friendship map. A, B, C, D, E, F. Okay, so there's my friends. A is friends with B. B and F. Okay. B is friends with A, that's convenient, C, and E. C is friends with B, with D, with E, and with F. D isn't friends with anybody? Looks that way. And E is friends with B, is friends with C, is friends with D, and its friends is F. Well, that makes it easy. So A, we want a possible seating arrangement. A, B, C, D, E, F. Okay, so that's possible, because I can just go around the outside of the circle. Well, actually, that's the B answer, because the A answer is my graph. All right, so my C answer. Is there a possible way for B and E to sit next to each other? Yeah, why not? B, E, D, C, F, A. Right? E can sit there, C can sit there, coming back to there. So yeah, there is a way. And thus ends chapter 6. See if there's oh, look at this. All these extra problems we could be doing. Yes, how wonderful. Well, I guess we won't do those. Do the problems not assigned? No, don't think so. No. We have much better things to do. All right, moving on to chapter 10. Maybe we can actually use our calculator in Chapter 10. Wouldn't that be special? Chapter 9 is pretty cool. It has colored graphs. Mathematics of money. That sounds good. Okay, we don't want to be there. We want to be here. How about 7? Don't we do 7? No, we don't do 7. I got,
No, we've only got 2 chapters, so.
no. 10, 14, 16.
Yeah, after this.
That's 3. Yeah, 3 chapters.
After this.
Yeah, but the class is almost done.
4 weeks, so.
Well, yeah, but 2 days are taken up in tests and finals, and that's only 3 weeks. This whole week is in testing.
That's all right.
Yeah.
I have 12 weeks left of school. I'm on countdown now.
Oh, excellent.
All right, let's not run it.
Yeah. Percentages. I hope you guys hold your dinner party when I can come.
Oh, well, I'll be partying in Stormway, so you can join.
Mhm.
I'll be moving in the next.
Oh, excellent. Excellent. Yeah, my wife tells me that next year is my last year.
Would be what?
How did you agree?
Heading in Stormlight. Oh.
Doesn't matter. Wait a minute. Does it? We gotta. Well, I have to do.
I finally had my last one trained, but it was just after 2 years you can only stand so much crap. Then it came into the curve, and then I know what it's like.
Okay, as a customer, we have to make decisions every day about money. Do we stop at a gas station and for where it's $5 a gallon cheaper, or do we not drive there? Is it better to have a new red Mustang and take the rebate, or is it better to get zero financing? Well, it's always better. It's always better to have a new red Mustang, and Daddy should have paid cash for it for you anyway, so shouldn't be a problem there, right? Decisions of the first type usually involve just a little arithmetic, some common sense. On a $20 fill-up, you're saving $1. So to make a U-turn, is it worth it? It all depends if you hit somebody during the U-turn. Decisions of the second type involve more sophisticated understanding of the time value of money. Is $2,000 up front more or less than the savings on the interest payments over the next 5 years? This latter type of decision and others are similar to what we're going to talk about, which means our calculators will be used. A general truism is that people don't like to deal with fractions. There are some exceptions, like a half. But most people would rather avoid fractions whenever possible. This is called fraction phobia. It's difficult to deal with fractions with different denominators. Well, not in the current set of calculators. You can just put them all in. It doesn't matter. One way to get around the difficulty is express fractions in a standard denominator, 100, which is a percentage. So some percentage would be divided by 100. Percentages are useful for many reasons. All right, so we'll stop for a moment and ask the question.
Oh, the red Mustang. Definitely take the 0%. I've been paying on my car a year.
Yeah.
Paid $1,331 in car payments,
Yeah.
but I don't even have $1,000 off my loan yet.
Yeah, bomber.
I'm down to like 4,200.
Bomber. Okay, so yeah, I have something here, and I get a 50% discount on it. So I have Coca-Cola stock. Anybody know what Coca-Cola stock is? Yeah, KO. So I got Coca-Cola stock. It went down 50% this year. It goes up 50% next year. Am I better off or worse off than I was?
Aren't you even?
Yeah, that's the whole point. So if it was worth $100 and it went down 50%, it's only worth $50, right?
So you first off.
And it's at $50 and it goes up 50%, then it's only worth $75. Isn't that nice? So there was a time in 2000, in 2001, in 2002, where my 401k went down by 15% every year because the stock market was doing such a wonderful deal of returning things, right? That's going to take a lot of time to recoup coming the other way. Yeah. So percentages are also deceiving because the first indication is I go up 50, I go down 50, I should be in the same spot I was, right? And it looks like that's not the case. What if we went the other way? We went $100 and we went up 50%. Well, now we're at $150, and now we go down 50%. Where are we going to be? $75. So, and again, you'd think if you went up 50 and down 50, you'd be in the same spot. But no, that's not the way math works. Which is normal, right? If there's an easy way to think about it, it wouldn't be easy. The English Lit class scored 19 of 25 on a quiz. 49.2 out of 60 on the midterm, and 124 out of 50 on the final. They should just get A's, right? Without reading further, can you guess the score? Well, probably not. I'm going to guess it was 72. Oh, bummer, I'm off. So anyway, 76 on the first one, and 82 on the second one, and 83 on the final. So 83 is my best score, I guess. And that's why we put our grades into some stupid grade book and have it just multiply and divide and do whatever it does, and whatever comes out is fine with me, type thing. Example 10.1 illustrates a simple but important relationship between decimals and percentages. So if I move the decimal point over 2 places, I can call it a percent. Move over 2 places, I can call it a percent. I move it over 2 places, call it a percent. Now, the calculators that you may or may not have may or may not have a percent key. Mine does.
I hope mine does.
So if I go 90%, I can go 90% times 5, and it'll give me a 4.5. So I don't have to move the decimal point. It'll do it using my percent key. And I don't even have to think about it. Imagine you take an old friend out to dinner at a nice restaurant for her birthday. The final bill is $56. Must have been a pretty cheap restaurant. Your find suggests that you should, the service was good, you should tip 3/20 of the bill. 3/20 of the bill. What kind of tip is that? 15%. Okay. I thought the service was good. Should leave more than 15%. Leave that when service really is bad. Anyway, although 3/20 and 15 cents are mathematically equivalent, the latter is much more convenient way to express it. So when was the last time you were in the restaurant and you multiplied the bill by 3/20? No, never have in my entire life. So the tip would be $8.52. Imagine you have a little discretionary money saved up and you want to buy an iPad. iPad option. Local electronics store, $399. 6.7% sales tax. Blah, blah, blah. 400 and something. That's option one. $400 for an iPhone? I don't have an iPad.
It's an iPod.
iPod. It just holds the
iPods
pad.
aren't even the big ones aren't even $400 anymore.
Somebody needs to redo these transparencies. When was this book written? Anyway.
I bought mine brand new iPod for
Yeah.
120.
Yeah, I think that's what I got mine for too.
Like my old Nano, I paid 120 for it 5 years ago.
Yeah.
Yeah.
All right. So at Hamiltonian Circuits, another local store, you get $415, but you happen to get a 5% off coupon that's good for any electronics process. So you could take 5% off the price and say you're really only paying $394. But you have to use the coupon, otherwise you're hosed. And then, but you still have sales tax, so now it's up to $420 a coupon. You combine the separate calculations of the discount into one. All right. So I could do that. Option 3, you found an online merchant in Oregon that sells it for $4.41. The price includes a 5% shipping processing charge that you won't have to pay if you pick it up at a local store or that store. It's much more than the local store, but you are in luck. Your best friend is driving to Portland and is coming to visit and can pick it up and save you the 5%. Which one should you do? So you do that and you say, well, my friend's paying for the gas, it's only $420. Therefore, option 3 is cheapest. Yeah, that's one way to look at it. Option 3 is definitely cheapest. So, percent increase. If you start with some quantity Q and you have a percent increase, X%, you end up with some quantity I. I is equal to 1 plus whatever the percent increase is times the quantity Q. Okay. Percent decrease. I went the wrong way. I touched my screen at the wrong time. Total loss of whatever. See this word right here? This word is really decrease. If you start with quantity Q and decrease it by X%, you end up with a new quantity. 1 minus whatever the interest is times the quantity. If I is the quantity you want, you get when you increase an unknown quantity by Q, then you divide. So this is the same exact formula we had before, except we put the stuff that was on this side of the equation underneath. So exactly the same. Dow Jones Industrial Average, hovering around 13,000. It closes at 1375. It closes at 13. Day 2 closes at 1329.5. This is an increase of that. Blah 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 blah. Yes. So on day 1 to day 2, it went up 1.2%. Percent decreases are often used incorrectly, mostly intentionally, in an effort to mislead the public. The misuse is usually framed in a claim that if a percentage increase changes A to B, then the decrease changes A to B. We already showed that. That's not true. Mislead the public. Great fanfare. The police reports the crime decreased by 200% in 1 year. He came up with this number based on a report that went down from 450 1 year to 150 the next year. Since an increase from 150 to 450 is 200%, which is true, the decrease from 450 must surely be the same. Wrong, bogus. It was only a 66.67% decrease. Oh well, can't have everything. by way of exaggerating claims about the percentage increase of something. We report crimes, we report traffic accidents, we are politicians. To have 100% decrease in something, it has to go to 0. So if the murder rate is whatever the murder rate is, I had 100 murders last year. If the decrease is 100% decrease, I have to have 0 murders. An important part of being a smart shopper is to understand that they're out to get your money. Toy store buys a certain toy from a distributor, sells it at Christmas time. The store marks up the price by 80%, which is the intended profit margin. Unfortunately, the store doesn't sell, so it marks it down by 40% off the original price. After a while, an additional 25% markdown is taken off the price, and it's on the clearance table. But even so, the store still makes a profit on it. So we do that on the Air Force Base all the time. The exchange will have a 75% called previously marked down things, and it's sort of like being at a rummage sale. You just walk out with a great big bag of stuff. After Christmas, toys are marked down and put on the 40% tag off. The sale price is 60% of the original. This gives blah blah blah, which represents a 8% markup of the original store cost. The toy is put on clearance, 25% off the tag, blah blah blah. We have a net loss of 19%. That's what happens when a toy doesn't sell. Okay, well, let's see if there's some problems we can do. Probably not, because we don't start until problem number 11. And by number 11, we'll probably... No, number 11 has to do with percentages. Okay. So we'll look at problem number 11. And we can probably do 19 as well. Excellent. Total health care spending in the United States during 2005 was $2 trillion. $2 trillion. So much for significant digits, representing an approximate 16% of the gross national product. Estimate the gross domestic product of the United States to the nearest $1 billion. Well, you can't estimate to the nearest billion when you don't have your $1 trillion any more than $1 trillion. But that's okay. We'll do that. So, the gross national product times 16% equals $2 trillion. So the gross national product has to equal $2 trillion divided by 16%. 2 divided by 0.16. Boom. $12,500 billion. Estimate the gross domestic product in the United States to the nearest $1 billion. Well, I guess that's all we can do. Now, why would you want to do that? I don't understand. Oh, anyway, that's what we did. I got 12.5 trillion, and I moved the decimal over 3 places so I can answer the question with billion, even though I really didn't want to. Number 19, Warren Buffett's doing something. About time. There's something. Warren Buffett, who paid that much in federal income tax in 2006. Well, that seems like a nice amount. 142. They probably just made up this number. 2006. commented that he pays 17.7% of his income in federal tax, whereas his employees pay an average of 32.9% of their wages in federal tax. So, just because you're following the rules and regulations doesn't mean it's wrong. So A, what was Buffett's income? Okay, so his income times 17.7% equals 8,142,123. So his income, 8,14230 divided by 0.11177. Time to break out the calculator. Well, we could do it in our head, right? Yeah, sure. 8,142,123 divided by 0.177. Looks like $46 million. Now we know that's not true. It's got to be 46,100,000 or 46,50,097,42. You know, I can't possibly have it an even number. All right, B, C, D, B, B, B. In 2006, the Social Security tax rate paid only on the first $92,200 of income was 6.2%. What percentage of Buffett's income was paid in Social Security taxes? Okay, 94,200 times 6.2%. Doesn't matter that he made $46 million. He's only going to pay Social Security on $94,200 times 0.062. 5,840.40 dollars. Now, obviously, that question is there so that the bleeding art liberals in the class can moan and groan about he's not paying enough, right? Yeah, that's probably one of the questions there. But we really don't care how little or much he paid, right? I mean, he could have retired a long time ago and not paid anything, gave it all away, and moved to Arizona or something. See where some island in the Pacific or something. Oh well, and I guess that's done with that. Okay, so moving on to 10.2. Simple interest. Okay. And we'll pull this back a little bit. Okay, in 1972, a friend of mine borrowed $300 at 5%, which is more than I was getting before, simple interest. Okay, 20, 30, 40 years later, 2012. How much does he owe me? 300 plus 40 years at 5% times 300. Plus 40 times 0.5 times 300. $900. Do I care? No, because in 1995 I found the promissory note and I threw it away because he's never going to pay me. There's no reason to keep it. I'm never going to see the money. It really doesn't matter, does it?
$300 was a lot of money though back in 1972
It was, yeah.
compared to nowadays.
Yeah. I was getting paid, I think it was $58 every 2 weeks in my job. I was getting paid $2.15 an hour at the time
What was your job though?
as a Coca-Cola repairman.
I can't even
and-
hardly survive off $11 an
Yeah,
hour.
so between age 16 and age 23 when I entered the Navy as a Coca-Cola repairman, and I was getting $2.15 an hour. It never went up because the minimum wage never went up. And that was more than enough to buy an engagement ring for my fiancée-to-be and a pearl before the engagement ring. And, of course, gas was 30 cents a gallon at the time.
So $2.50, is that like a good paying wage?
At the time? Oh, yeah. Yeah. My other jobs I had were picking blueberries at 50 cents a bucket. And on a good day, as long as I picked more than one bucket a day, then that was more than I was making delivering papers. So there was a day I picked 10 buckets. That was a really great day. My average day was 5. So I'd make, 5 buckets, $2.50 for the whole day. And as a kid, you think that was pretty good. That would buy shoes and a pair of socks and okay, well.
Your $50 every 2 weeks doesn't even fill up my gas tank.
Yeah, that's right. $58 every 2 weeks would not. Yeah.
Insane.
Yeah,
You could buy milk.
Now on the $2.15 an hour you can. Milk at Walgreens is $2.99.
Yeah, 1950. Oh, today. Which costs more, a gallon of milk or a gallon of gas?
Gallon of gas.
Yes.
In 1950, which costs more, a gallon of milk or a gallon of gas?
Gallon of milk.
That's right. So in 1950, milk was 79 cents a gallon, and gas was 25 cents a gallon. Today, milk is what? $3?
$2.99.
$2.99 a gallon for milk, and $3.29.
No,
Or
gas
gas.
is like
So-
40 something.
Yeah.
If
So
you're
it-
here, it's $3.29.
What?
She just filled her up
Where at?
a Buc-ee's, like coming right off the interstate. And Quick Trip and all that other stuff.
The Casey's right down here. Well, I guess I haven't looked because I don't need gas yet. So
I haven't looked either.
All right. So
I just saw it coming in. It's like 3 something over. It's like 330 or 40 over in Omaha.
So
I was
the
always
cost of
around
milk
that.
has not kept up with inflation.
and people come to Iowa to buy groceries. For
The gas has.
So if we were paying $9 a gallon for milk right now, we'd be paying the same as your moms and dad, your grandmothers did back in 1950. Yep. Pretty cool.
I'll just get it
Anyway,
filled
back to
out.
where we were. So simple interest. Present value, promise to pay, expected amount, blah, blah, blah. There's an annual percentage rate associated with it. And the annual percentage rate is the most important variable in computing the return on an investment. And sections 2. And in the next chapter, we'll worry about compound interest. Simple interest. The original amount invested or borrowed is called the principal. It generates interest over time. This is in contrast to compound interest, where the principal generates interest, and then the principal plus the interest generates more interest. I'm more interested in that. Okay, but simple interest, the interest is never, you don't get interest on the interest. One day you were born, your parents purchased $1,000 in savings bond at a 5% annual return. and now it's way later. That's only $50 a year they're getting. And first birthday, second birthday, 18th birthday. So it almost doubled. The final value is the principal plus 1 plus the rate times whatever the time is. R denotes the rate. You have to put it in interest. You think of simple interest as a formula: present value, future value, time, interest rate, blah, blah, blah. U.S. Treasury bonds paying 4.28%. When did they do that last? Anyway, I had, when I left the Navy in 74, I had some U.S. Treasury bills, the savings bonds, from when Jimmy Carter was president. Now, when Jimmy Carter was president, the interest rates were 18% or so. And these bonds were for 30 years, they're going to pay me 9.5% interest. They went up quite well. I had a whole stack of them. They mailed them to me. Future rate, blah, blah, blah. So the
So you're not in the Navy anymore, are you?
That's a good question. Government bonds. So I have a formula, I'm going to use it. Generally speaking, credit cards charge high interest rates. Why? Because they can get away with it.
Alright, see you later.
If you're paying a lot of interest and just pay off the bill. Well, obviously I didn't do that, but I should have. In the later case, you will get free of the short-term loan from the company, blah, blah, blah. Excellent. Yeah. Imagine that you recently got a new credit card and it's a 24% interest rate and you have a new balance of $876. Isn't that nice? And you pay $20 off on the principal. What's going to happen? The principal is going to go up. That's right. So if you pay the minimum payment of $20, the next month your bill is going to be $16.65. So obviously that's not a good idea.
Well, they set the interest rate in your minimum payment to where you just barely take your balance down.
Oh,
It's
yeah.
only like
Yeah, I
$3
know.
bucks.
It is so wonderful. Isn't that great? Almost as good as student loans, right? Yeah.
I haven't started that one yet.
Yeah. I had $250 in student loans when I graduated from Michigan State.
Okay, nice. I know.
Isn't that disgusting?
But what
That's
was
total.
tuition back then, though?
Tuition?
Probably like nothing.
Well, first of all, I didn't pay anything. Because-
That's right. You
because-
were in the Navy.
No, I wasn't in the Navy, but I was the oldest of 5, and my father's income was less than $10,000 a year. And the calculation said at that point, at $10,000 a year, your family didn't have to pay anything. So I went to a state school, room and board, tuition was free for the whole 4 years I was there. Now, the thing that disgusts me, back to what we're doing here, good credit, bad credit, ugly credit. Finance charge of $21 calculated, blah, 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 blah. Okay, well, those are all calculations. Periodic rate, APR. I have some credit cards that are at 22%, 24%, whatever that is, interest rate, but they're locked up in a safety deposit box and I never use them. You know, Sears, gave me a credit card, 50% off my purchases and $10. And so I got it. And then I read the small print and they wanted 24% interest. And I said, well, that's interesting. It's locked in a safety deposit box. I'm not going to use it at all. Nebraska. The credit card I like is Von Maur. You guys got a Von Maur credit card?
No.
Why not?
I like the little gifts you get in the beginning of the month.
Yeah. The
Having a credit card?
the Von Maur credit card has no interest, ever.
I like my Nebraska furniture
Yeah.
mark one right
Oh,
now.
yeah. I have a Nebraska furniture one, marked one too.
I have no interest for
yeah.
another 2 years.
Yeah, that's the only time I use it is to buy something at no interest for some amount of time, and then I make sure I have it paid off before that amount of time's up.
I was a dumbass and maxed out 2 credit cards with a 24% interest rate.
Mm-hmm. Yeah, I would say that's pretty much dumbass. Yeah. Pretty much.
But I took my ex to court and I'm getting it all back.
Oh,
My
excellent.
cards are in my safe,
Yeah.
and they're locked away.
Yep.
So I don't use them.
Yeah, and I always get two, right? So I have mine and my wife's, right? Well, either if the credit card my wife has, my card's locked in the safety deposit box.
But you still end up getting a credit card
and
off.
Yeah, and all the cards I keep are locked up there, and all the cards that we have that we don't use. So the Nebraska Furniture Mart card, I don't keep it in my wallet because you can just go to the cash register. I want to charge it. Here's my phone number and here's my ID card, and oh, okay. So you don't need it. Same thing with Von Maur. You don't need to
That's
carry
why.
your credit card with you. They'll figure out what it is. Yeah, same
That
thing.
happened to me at Best Buy.
Yeah, Best Buy is the same way.
Right.
So you could have a credit card. Somebody could claim to be you, and you could be hosed. Yeah, that hasn't happened to me yet. But the other thing that was cool, and it was a Navy Federal Credit Union credit card, and this credit card is locked up in a safety deposit box in Belleville. And the physical card that's locked up in the box was used in a store in Virginia to charge $500 on. And it's a card that I've never used ever. It's one my wife carries, but it's my card. It's locked up. They somehow got made a physical copy of my card and used it. And the computer fraud people, there's a fraud service associated with your credit cards. Flagged that right away, stopped the payment, never paid it at all, took it off my credit card thing. It was totally amazing how quickly it all happened.
See, that happened to me with my debit card.
Mm-hmm.
It was in Pennsylvania, though.
It was in Pennsylvania without you.
And they bought some gym equipment worth $2,500.
Mm-hmm.
And I was like, I can buy no gym equipment. I swear to God, I don't live in Pennsylvania. I don't know where this is.
Yep.
So my bank, thank God, gave me a new debit card, and
Yep.
they stopped the payment and
Yeah.
whatnot. But
Yeah. It's a
scary.
scary situation. Yeah. So those things happen. I travel to Connecticut often. My Bank of the West people, they don't want me to leave the area without telling them. So as soon as I get in the car to travel to Connecticut, I call them up. I'm on my way to Connecticut. I'm driving down I-95, and now I can use that card all the way there, all the way back. You call the American Express people. Nope, we don't need to know. We know who you are. We know what you're going to do. You're not going to do anything different than you've done in the past. We know that. The computer knows that. Don't worry.
When they call and when they question everything, my grandma
Yeah.
had that problem
Mhm.
when she was down in Arizona.
Yeah.
And they call and say, well, there's an amount on the card that, we've never seen it happen before.
Yeah, exactly.
And she didn't know if she was senile, of
Mhm.
course.
Yeah.
They didn't know how to explain.
Yeah.
But we got it all straightened out because, she used it. She just didn't remember what she used it for.
But the fraud programs that are part of our credit card system are really good, and they protect us quite a bit.
Well, because the reason I wasn't here Thursday or Monday, because I was in Minnesota for
Mhm.
Easter, and I don't know. I guess it's a good thing, but then again, with me, it was a pain in the butt because we have a set limit we can spend a day
Yeah.
and we went over it, and we couldn't call the banks because our car broke down, and we couldn't call the bank because it was late at night to get our car fixed, and I was like, great, I'm stranded in hillbilly little town. This is ridiculous.
Yeah.
Yeah.
What checks are for.
Oh, trust me, I don't know how to write a check. I use my debit card.
That's not.
Yeah, I don't carry checks.
I have a friend that doesn't know how to use her debit card. All she does is write checks for everything. She doesn't know how to use the debit card.
My wife got a debit card 20 years ago. She stuck it in the machine. She put her number in wrong 3 times in a row. The machine kept her card. She hasn't had another one since. She doesn't want one.
See,
No. She went and wrote down her PIN number on her checkbook so she could remember it, and she wrote it down backwards so it'd be different than what it really was, and then she forgot she wrote it down backwards. Anyway, so it's just one of those things. 20 years ago, and she hasn't had a debit card since.
they're not that bad.
Yeah. And we had there's only so many pins you can remember, and there's only so many passwords you can remember. I reached my limit, and I had to call one of the credit card people and say, turn the paper back on. We can't be paperless because I can't remember that login and password.
I know, I can't, I'm not paperless. I want my bill. I need
Yeah.
to see something in front of me.
Yeah, I'm paperless on most of what I do, but I had to cut back on one because it was just, I couldn't do it anymore. Couldn't remember that many. Used to be able to. The balance is subject to a financial charge. And normally they take an average balance and come up with that financial charge. All right, well, that's good. Financial charge, blah, 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 blah. 2 important lessons. Make sure you understand the terms of your credit card agreement. They're normally variable interest rates now. So as long as they're hanging at the top end of their rate, they're going to charge you as much as they can. As you pay them down, they start charging you less interest because they're trying to encourage you to move it up. They make a real difference, blah, blah, blah. And maybe someday I'll get mine paid off. I doubt it. All right, well, let's see. I think 2, 3, 4, 5, 6. I think that's probably enough. We'll stop there. We'll do a quiz, and we'll finish off chapter 10 on Monday, and then we'll do the test on Thursday. That would be good. So we made that.
Yeah. 19.
Hmm?
We're stopping at number 19.
Oh, we gotta do another problem, don't we?
We can do it Monday.
We can do it on
that's
Monday.
Let me see. No, we should do a simple interest problem. You're right.
How are you? Sorry. I have something down.
Yeah, we should do. Yeah, we should do 21 and 29. I promise to do it quick.
They'll make it quick.
Number 21. Suppose you buy a $875 savings bond that pays 4 times and ends up determined 4 years. Okay, so we're going to go. A is going to be 875 plus 4 times 0.0428 times 875. And then B, 5 years. 875 plus 5, 0.0428, 875. Suppose you do it for 10 years. 875 plus 10, 0.0428, 875. Time for calculator and changing colors. That's not very much. 1024.8. Ten 62.25. 1249.5. Okay,
Is it 2.5 or just 5?
0.5. I don't know. Yeah, 0.5. So we should add a 0 here and a 0 there, and we should probably put dollar signs in front of these so that it looks like it's dollars. It kind of looks like we know what we're doing. Number 29. You would like to buy a bond earning simple annual interest that will double in 12 years. Determine the interest. Okay, so my amount plus 12 years times the interest times the amount is going to be 2 times the amount. Okay, so I can divide everything by n. 1 plus 12i is equal to 2. 1 goes on the other side of the equation, give me a 1. I is equal to 1 over 12. 1 divided by 12. 8.8 1/3%. So I would need 8 1/3% interest if I wanted to double something in 12 years using simple interest.
It's a long time though to double your money.
Yeah, pretty much. Pretty much, yeah. Yeah, you're not going to get rich quick on simple interest.
No, that's for sure.
Okay, we'll pass out the quiz. Long quiz. Right quiz.
Oh, come on.
I used to watch Days in Our Lives.
Oh, yeah.
Oh yeah, I used to watch that when I was a little kid too.
I love that one.
I told her, I go
Thank you.
on SoapNet, they're doing 50 hours of General Hospital for their 50th anniversary, and I'm watching it.
And so you're gonna stay up 2 days straight to watch it?
You gotta watch Luke and Laura's wedding,
And you know what?
and God knows what else.
Oh my god. Oh man. Take your time.
Okay, we ready? Anybody got an answer for 1?
A.
A's wrong. Anybody got another answer for 1?
I see.
B's wrong. Anybody got another answer for 1?
B.
B? No, B's wrong.
D.
Delta is the correct answer. And I know that I said that earlier today. I said,
But that was over
yeah,
an hour and a half
yeah, that was an
ago.
hour and a half ago, I know. So brute force is optimal. So it can either be B or D. So optimal, it will get the best one. But it's inefficient. It takes too long. So that's what makes it D. Okay, anybody got an answer to 2?
A.
I guess C.
Excellent. No one has the right answer. It's delta.
C?
Yeah. So if I have a complete guy, means that everybody is connected to everybody else. So everyone's connected. If I start here, so this is a complete graph with 4. If I start here, how many paths do I got? 1, 2, 3. So I have 3 different paths. From each of those paths, how many do I have? When I get there, I have 2. 1, 2, 1, 2, 1, 2. And from the last guy, I have 1. So I have 3 possibilities, and then I have 2, so times 2 times 1. So a K4 graph, a complete thing of 4 vertexes, has 3 factorial paths that you could take. So if I had K12, that'd be 11 factorial. I have K11, so K11 would be 10 factorial. So at the very first guy, I have 10 different possibilities, leaving the first guy. When I get to the second guy, I only have 9. When I get to the third guy, I only have 8.
Okay.
And then 7, and then 6, and that's why it's 10 factorial. Okay, you guys are doing so well so far. I'm really impressed. Where's Scott when we need him, anyway?
I guess E for 3.
Echo. So we have an E, we have an A. Huh? E, A, and A. Okay, well none of those are right. So it's cheapest link. Okay, so that means we choose 3 first, because he's the cheapest. We choose 7 second, 8 third. We can't choose 20 because that would close it. We can't choose 10 because that would close it. So we got to go to E next, and then at that point we have to complete it. So to complete it, we'd have to go.
Start at A.
No, cheapest tour is done irregardless of where you start, and then where you start is what your final answer is. Okay, and then E to, I don't have something E to B. What's it, 15? Cheapest. We got to move back because I forgot to put 15 here. Okay, there, that's better. So I choose 3, I choose 7, I choose 15, and then boom, boom, boom. To complete it, I have to go that way. So now I need to start at A. So I'm going to start at A, and I can go A, C, D, B, E, or I could go A, E, B, D, C, ending in A, ending in A.
That A, C, D, B, E, A is what I had my first time.
Yeah.
Should have left it.
A the first time we do that one.
Mm-hmm. But that's what you do. You choose the road. You choose the cheapest link first, and then the second cheapest link, and then the third cheapest link.
Yeah, but
the right answer is B.
A, E. Well, I don't know. Right answer might not be there.
because if you add them up total round trip, because you're looking for the cheapest, The cheapest way to go is
No.
A, C, E,
No.
B, D, A.
Cheapest link is a way of doing it. You pick the cheapest link first. So there's the nearest neighbor method. The nearest neighbor means I start at A. My nearest neighbor would be C. So I go A to C if I was. So I have a nearest neighbor way, and I have a cheapest link way.
Which one's the answer then?
Oh, I don't know. I haven't figured that one out yet. It has to be one of those. And so, oh, that's A?
Yeah.
Okay, so A was right. Bummer. Two of you got it right.
It's okay, you can one more.
Yeah, all right.
We don't exclude.
All right. Number 4, same answer as before, so that would be,
Technically, I did have it. C.
Yeah.
Right answer.
There you go.
so the correct answer to 4 is
A.
B.
B. B. That's what you meant to say, B, right?
Yeah.
Yeah, you meant to say B, okay.
B.
All right, good. Okay. Now, we're going to do this guy, and we're going to do it cheapest link again. So, cheapest link means we pick 1, then we pick 2. We can't pick 4 because that would be 3 to the same guy. So we have to pick 5, and we have to pick 9. And then it wants to know how many miles is it. So 9 plus 5 plus 1 plus 2. 17?
Yeah, A.
A. All right, put your name and your score, which is 100, in case you were wondering, on your quiz. Pass it in, and I'll see you on Monday.